Today we're going to learn about plate tectonics distribution, presented to you by Group 1 Betelgeuse. So, to understand plate tectonics, we must first have a knowledge on the internal structure of the Earth. As we all know, the Earth is divided into three layers: the crust, the mantle, and the core. Let us take a look inside the crust. There are two different types of crust: the thin oceanic crust that underlies the ocean basins, and the thicker continental crust that underlies the continents. These two different types of crust are made of different types of rock. The thin oceanic crust is composed primarily of basalt, and the thicker continental crust is composed primarily of granite. The low density of the thick continental crust allows it to float in high relief on the much higher density mantle below. Next stop, Earth's mantle. Earth's mantle is thought to be composed mainly of olivine-rich rock. It has different temperatures at different depths. The temperature is lowest immediately beneath the crust and increases with depth. The highest temperatures occur where the mantle material is in contact with the heat-producing core. This steady increase of temperature with depth is known as the geothermal gradient. The geothermal gradient is responsible for different rock behaviors, and the different rock behaviors are used to divide the mantle into two different zones. Rocks in the upper mantle are cool and brittle, while rocks in the lower mantle are hot and soft, but not molten. Rocks in the upper mantle are brittle enough to break under stress and produce earthquakes. However, rocks in the lower mantle are soft and flow when subjected to forces instead of breaking. The lower limit of brittle behavior is the boundary between the upper and lower mantle. Last is the Earth's core, which is mainly composed of iron and nickel alloy. The core is divided into two different zones. The outer core is liquid because the temperatures there are adequate to melt the iron-nickel alloy. However, the inner core is solid even though its temperature is higher than the outer core. It is because here, the tremendous pressure produced by the weight of the overlying rocks is strong enough to crowd the atoms tightly together and prevent the liquid state. Now that we know all about the internal structure of the Earth, we may now learn that the Earth's crust is broken up into pieces called plates. Heat rising and falling inside the mantle creates convection currents generated by radioactive decay in the core. The convection currents move the plates. Where convection currents diverge near the Earth's crust, plates move apart. Where convection currents converge, plates move together. The movement of the plates and the activity inside the Earth is called plate tectonics. Plate tectonics cause earthquakes and volcanoes. The point where two plates meet is called a plate boundary. Earthquakes and volcanoes are most likely to occur either on or near plate boundaries. This map shows the world's tectonic plates. The boundary where two separate plates meet is where all the action occurs and is called a fault. A fault is a crack in the Earth's crust resulting from the movement of the two plates. There are a number of different types of plate boundary. First is the destructive plate boundary. A destructive or convergent or compressional plate boundary occurs when plates move together. It can be oceanic continental convergence, where the oceanic plate is forced under the lighter continental plate. Friction causes melting of the oceanic plate and may trigger earthquakes. Magma rises up through cracks and erupts onto the surface. An example of this convergence is where the Nazca Plate is forced under the South American Plate. Another type of convergence is the continental-continental, where two continental plates collide. Neither plate is forced under the other, and so both are forced up to form fold mountains. An example of this is the Himalayan mountain range. Another is the oceanic-oceanic, where two oceanic plates converge and subduction occurs. Another type of plate boundary is the constructive or divergent or tensional plate boundary, which occurs when plates move apart. Volcanoes are formed as magma wells up to fill the gap, and eventually new crust is formed. An example of a constructive plate boundary is the Mid-Atlantic Ridge. A conservative or transform plate boundary occurs where plates slide past each other in opposite directions, or in the same direction but at different speeds. Friction is eventually overcome and the plates slip past in a sudden movement. The shock waves created produce an earthquake. This occurs at the San Andreas Fault in California. The evidence for plate movement are as follows. Number 1. The shapes of many continents are such that they look like they are separated pieces of a jigsaw puzzle. For example, you can see on the map that the shape of the east coast of North and South America is relative to the shape of the west coast of Africa and Europe. Number 2. Many fossil comparisons along the edges of continents that look like they fit together suggest species similarities that would only make sense if the two continents were joined at some point in the past. Number 3. There is a large amount of seismic, volcanic, and geothermal activity along the conjectured plate boundaries. This is shown clearly on the map here, where the distribution of earthquakes and volcanoes are plotted. The concentration is striking, and indeed this plot serves to define the plate boundaries extremely well. The string of volcanoes and sites of seismic activity or earthquakes is called the Pacific Ring of Fire. Located around the edges of the Pacific Ocean, roughly 90% of all earthquakes occur along the Ring of Fire, with 75% of all active volcanoes on Earth. This is the result of plate tectonics. Number 4. There are ridges such as the Mid-Atlantic Ridge, which was shown earlier, where plates are separating, which are produced by lava welling up from between the plates as they pull apart. Likewise, there are mountain ranges being formed where plates are pushing against each other. A mountain range is a group or chain of mountains located close together. Since neighboring mountains often share the same geological origins, mountain ranges have similar form, size, and age. Example of this is the Himalayas, which is still growing. As said earlier, earthquakes and volcanoes are the results of plate tectonics. Volcanoes are formed when the magma exerts pressure on the rocks until it cracks the rock. Then the magma squirts into the crack and starts building pressure again. Every time the rock cracks, it makes a small earthquake. Most earthquakes occur at fault zones where tectonic plates collide or slide against each other. These impacts are usually gradual and unnoticeable on the surface. However, immense stress can build up between plates. When this stress is released quickly, it sends massive vibrations called seismic waves, often hundreds of miles through the rock and up to the surface. Other quakes can occur far from fault zones when plates are stretched or squeezed. On average, a magnitude 8 quake strikes somewhere every year and some 10,000 people die in earthquakes annually.